Hi, we continue the section, the 4H. So this time that we introduce the decreasing annuity. So the notation. So if an annuity is decreasing linearly over time, the present value of that annuity is called the DA right angle N. So we have time point 0, 1, 2, 3, up to N, and the payment amount is N dollar at time 1, N minus $1 at time 2, N minus $3 at time 3, and $2 at N minus 1, $1 at N. So present value of this is named DA right angle N. So decreasing, so we have D instead of I. And the theorem, so the DA right angle N is equal to N minus A right angle N over I. So it has a simple shape. And I is the annual effective interest, which is constant. And actually the proof is straightforward. And actually this theorem is the corollary of the previous corollary. So the theorem, so let P is equal to N. So because the first payment is N, and Q is equal to -1 because we have $1 decrease each year. Then if you just plug in numbers in the previous one, then this DA right angle N is equal to, so P times A right angle N. So remember that this was P in the formula, and plus Q, but the Q is -1, so Q times A right angle N minus N times V to the power N over I. So we can do some algebra. So this is equal to, okay, so we put I in the denominator. So the numerator becomes I times N times A right angle N. But A right angle N is equal to 1 minus V to the power N. It's a little bit crowded. Over I. And the minus A right angle N minus N times V to the power N. But okay, so we have the negative sign here and the negative sign here. So in total, the plus N times V to the power N. And actually several terms cancel. Actually 2 terms cancel. So N times Vn and the I times N times negative V to the power N over I. So these terms cancel. So that becomes, so this becomes, this is simplified, and this is N minus A right angle N over I. So this is the end of the proof. So the point is that once we proved the previous corollary, it's general for all P and Q. So this theorem can be derived from that corollary. Yeah, so now that we have an example, so we're going to calculate the present value and also the accumulated value of the annuity, so decreasing annuity. Okay, so example, we have 25 years. So 1, 2, 3 up to 25. And the payment amount is $100 at time 1, and it's decreasing over time. So next year, $98.96. And we have 50 payments. So the last payment is 52. Sorry, the 25 payments. So the last payment is $52. So each year that we have $2 less than the previous year. And the assumption is annual effective interest rate is 4%. Then the solution, actually, we derived the theorem, but we don't use it, and we directly apply the corollary. So this time, the P is 100 and Q is -2. Then what is the present value? Present value is P times A right angle N. So 100 times A right angle 25 at 4%. And -2. So this is the plus Q times A right angle N. So A right angle 25 at 4%. We have 25 payments minus the 25 times V to the power N. So V is 1.04 to the power -1. So 1.04 to the power -25 over I. I is 4%, so 0.04. So you can calculate this part in BA2 plus. Then you can get this number as 15.62 to 1. So the 100 times 15.62 to 1. So 1,562.21. And -2 times the same quantity. So 15.62 to 1 minus 25 times, so this is 0.737512. And over 0.04. So now that we can just calculate these numbers, and this becomes 1,250. So present value of this annuity is $1,250.